All right, here we go. 4.3. Thanks, RC, for reminding me to put on the recording. All right, so vertex is represented by V. We know vertex is a point, right? We know it is what point on a parabola?
The highest or lowest.
Yeah, the highest or lowest point. Thank you. So in this particular case, we have all of our equations in vertex form. So they should tell us something about the vertex. Remember, the vertex is H and K, right? Where this formula, it's negative H plus K on the end. So what would be the vertex for this formula? Yeah, you did?
I think it would be 5, 4.
Okay. Now is it 5, 4 or negative 5, 4?
5.
Okay. So it is positive 5, 4 because the formula, remember, for vertex form looks like this. Y equals A x minus H squared plus K. That is our vertex form. This is in vertex form. So when H is negative here, it becomes positive here because of that negative sign in the formula. Okay? Next one. Josiah, what is the vertex for this formula?
7.
Okay. It's 2 points, right? An x and y value. So what are they?
7 and 4.
Okay. 4 and 7, but is it positive 7 or negative 7? It's negative 7, right? Because it's positive there, so if we know if we put it into the formula with a negative, it has to be negative 7. Does that make sense? All right, let's get these other vertex quickly. Chinir, what's this one?
Negative 1 and positive 4.
Yep. Rudy?
5 and 7.
Yep. 5 and?
7.
No. See the negative sign? That has to go with the K because the K is positive K. So if it's positive K here, it's negative 7. That negative 7 is actually the K value. Okay? Teodi, what about this one?
0 and 11.
Sorry?
0 and 11.
Very good. Yep. 0 and 11. Okay? Axis of symmetry. What is that? RC, do you remember what axis of symmetry is? Axis of symmetry. Who can tell us what it is? Douglas.
It's the line through the vertex.
Yes, it's the line through the vertex. So if this is our parabola, it's this line that goes here, through here. So what it is, it's actually the x value of the vertex, right? So we know it's going to be an x value because it's a vertical line. So they're all going to start off with x equals. All of the axis of symmetries are x equals. Okay, so Andrew, the first one, what would it be?
5.
Yeah, 5. Okay, KG?
Negative 7.
Negative 7. Jaden? Negative 1. Adrian?
0. Or 5.
And RC? Good. All right. Now, the step pattern. We know the standard step pattern is 1, 3, 5. This is for y equals x squared, right? That's when the a value is 1. When a is equal to 1. So what would be the step pattern for this? Our a is 3. Douglas.
It's going to be 3, 9, and 15.
Yeah, so basically you take your step pattern and you times it by 3. So it's going to be 3, 9, 15. Okay? Step pattern now for negative 3. Lucas. Yep. 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 Okay. Liam. Yep. Okay. Stefan.
Negative 5.
No. So here we had just, the A value here is -1, Stefan. So you're going to do -1 times these three numbers. So your first one would be?
-1.
Yep. -1 times 3?
3 and 5.
No, -1 times 3. Just can, yeah, -3 and?
-5.
Nice. Okay. And then Alan, what's my step pattern for this one?
3 and 5.
Yeah. Nothing changes, right? Because A is 1 here. All right. Any questions with this table? Nice. Moving on. All right. Oh, yeah.
Oh, nothing is like, is it always 1, 3 and 5, or where does the 1, 3 and 5 come from?
From yesterday. Were you here yesterday?
Yeah.
Okay, 1, 3, 5 would. Sorry?
Yesterday we didn't do a lesson.
Sorry, not yesterday, the day before. The last time we had a lesson. You weren't here. Were you?
Yesterday.
You were here?
Yeah.
All right. Where does the 1, 3, 5 come from? Someone want to tell him while I draw this out? We're going back here now. We're going back reverse. It comes from this step pattern. 1 over, 1 up. 1 over, 3 up. 1 over, 5 up. Okay? Directly from the table of values from y equals x squared. That's where it comes from. Okay? Now if you put a 2 here, well, you're going to multiply all of these steps by 2. Okay? All right. Sketch a graph of the parabola y equals -2 x plus 4 squared plus 8 and label it frilly. So what is the vertex here? Adrian. Very good. -4, 8. I'm going to go right there. There's my vertex. Okay. Your axis of symmetry, which is this line down here, is, Andrew? Sorry?
Axis of symmetry is -4.
Yeah, x equals -4. Okay? That's how you would say it. All right? Next, our step pattern. Step pattern is going to be associated with our A value. Our A value is equal to -2 in this case. So that's the what you want to multiply the 1, 3, 5 by. Okay, Rudy, what's the step pattern going to be?
-2, -6.
Good. That's our step pattern. Okay. Now, why is that step pattern important? Well, now it allows us to create this graph very easily, right? So I'm going to go over 1 and I'm going to go down 2. So 1, 2. There's my point. Then I'm going to go over 1 and I'm going to go down 6. 1, 2. Oh, you can't see? Sorry. 1, 2, 3, 4, 5, 6. I'm going to go over 1 and down 10. Okay, and then it's just mirrored on the other side. Okay, so I have my parabola. Okay, just from the step pattern. Right? It says describe the set of values that x may take. There's my axis of symmetry. So what can the values of x be? So remember, x is the horizontal axis. Okay? So because my line is passing through all of these numbers, all the fractions, you know, it's passing through -3, -6, -5, -4, -4.5, -3.25. It actually passes through all of the numbers, and it's continuing to go like this. It's going down. It's going down and to the sides. For how long? Forever. So although it is covering, it's going down much quicker than it's going to the sides, it's still going to the sides. So assuming it's infinite, it's going forever, it's going to hit all of the x values. It has no limit. It's going forever. So the way we would say that is we would say x may take,
Sorry, would I ever get black?
no, may take any real number as a value. So it can take any real number as a value. And the way we do that in kind of short form is we say XER. We do it in this sort of italic letters. And that means X are all real numbers. Not sure why it's E, but oh, this symbol means belongs. X belongs to all real numbers. So if you see that XER, it's saying X is every number. Okay? Then it says describe the set of values that Y may take. Okay? Can Y be plus 10? Jaden, what do you think? Sorry?
No.
No, it can't. Never gonna go to 10. It's never. Could it be minus 6 million?
Yes.
How about 6 trillion?
Yeah.
Yeah, it could be, because it's gonna go there eventually, right? It's going down, down, down. So describe the set of all real numbers for Y. We're gonna say Y belongs to all real numbers set, yeah, smaller, or you could say less than, smaller than 8. Okay? And the way you would write that is you would say YER, so Y is all real numbers, Y belongs to all real numbers, where Y is less than and equal to 8. That's how you would write it. Okay? This weird number formatting, YER, that's all going to go all the way to grade 12. So in grade 12 calc, you're going to see that in day 1, the lesson, they're going to talk about that. Yeah.
What does that R mean?
All real numbers. Belongs to real numbers. It's like a weird fancy R. It actually looks like that with 2 lines. I think it's like Roman or something, or Latin. Sounds right. Okay, next page. Let's go. I want to try and get through this. Example 2. We're going to go a little bit quicker here. It's the same idea here. Looking at example 2. Oh, sorry. This is example 3. Okay, who wants to tackle this whole problem by themselves? Okay, Ethan, let's go. Let's do it. Vertex.
3, -3,
Yep. Axis of symmetry.
3.
No. X equals.
Oh, x equals
Okay. Step pattern, your A value is what?
2,
2. Okay. So what's your step pattern?
2, 6, 10.
2, 6, 10. Right? You're going to multiply that to 1, 3, 5. Okay. Your values of X may take what? Yep. So all real numbers. Your values of y,
All real numbers smaller than -2.
all real numbers, such that y is greater than and equal to -2, right? They got to be more, okay? And now if we want to graph this out real quickly, the vertex is 3 and -2. That's always where we start. Our step pattern is 2, 6, 10, so 1 over, 2 up, 1 over, 10 up, sorry, 6 up, okay, and you have your graph. Like that. Okay, here's our vertex. Here's our axis of symmetry. Any questions with this one? No questions? That one's pretty easy, straightforward. Moving on, example 4. We're going to match each relation with its graph now. Okay, so here we have, you can see this, we have A, which is this guy, B, and C. So let's think about it. This one has compression, so which graph do you think it would be? RC. It has 0.5 compression, so do you think it's going to be B, do you think it's going to be C, or do you think it's going to be A? Okay, well C, which one looks more compressed, C or A? This one's A. Yeah, it's going to be A, right? Just because of the compression. We didn't even have to go to the vertex. The vertex is probably the easiest thing. The vertex here is what? 3 and 2, right? So we go over to 3, go up to 2, so we know that's A. Let's find this one by the vertex, Jaden. So what's the vertex for this? Yeah, good. -3, -2. So here's the vertex. So which parabola is this? B, A, or C? B. Okay. And this one over here, Max's. It's going to be what? What's the vertex?
It could be 4, -1.
Yep, so if I go over to 4, -1, here's my vertex. So which parabola is it?
See?
Yeah. Okay, values x may take. They're all, for all of them, x can take all real numbers. Okay, values of y can take for A. So it's going to be, for all of these, it's going to be y is all real numbers, where A is going to be what? Y has to be what for A? This one's A. So here's my vertex. Teodi. Here's A, Teodi. What's the vertex? It's 3, 2. So what's the y values? They have to be, yeah, greater than and equal to 2 because they're touched 2. So it's equal to 2. B is going to, you're going to look at the vertex for B. Here it's going to be -3 and -2. Because we're interested in y, we're looking at the -2. And it opens up, so y is greater than and equal to -2. And finally, the last one, y is greater than or equal to -1. Any questions? Okay, next one, 5. Match each relation with its graph. The exact same thing here. First one, let's just find the vertex. I think that's the easiest way. They all open down, they're all negative. The vertex for this one is, Jadane, what do you think the vertex is?
1, -4.
Sorry?
1,
Yeah, it wouldn't be 1 though, because this, remember this sign gets reversed because of the formula? -1, -4, so let's find that. Go to -1, go down to -4. Uh-oh, we got a problem. 2 of them are on the same vertex. C and A. A and C. Okay. Which one do you think this is, Jadane? A or C? The way you would tell is by looking at the A value. So it's -2. So does that mean a stretch or a compression? Nope. When it's above 1, it's a stretch, right? Like, so it's going to be, what's this one going to be? A. Okay, this is the one with the same vertex down here. I know because it's +1 and -4. So we know this one is C. And then this one has to be B, because our vertex is +1 +4 up here. Okay. X is going to be, in this case, all real numbers. Y is going to be all real numbers. Where for A, we are Y is less than and equal to -4. C is the same thing. And B is less than and equal to 4. Yeah. Not in, I don't think in grade 10, no. But later. There's actually, you get to university with mathematics too, you actually work with imaginary numbers, which is not fun. I couldn't even tell you that much. That's when I started to lose it a little bit. Math gets very theoretical, gets closer to physics when you get to that level. But just to give you an example, like, you know how we can't square root a negative number? You guys know that? Like, two numbers can't multiply to give you a negative. With imaginary numbers, they can. That's where they come into play. Yeah. That's kind of all I can tell you. What? There's presumably some applications for it. Again, I don't know. You could Google, like on YouTube, purpose of imaginary numbers. But there's some reason for it. I think a lot of it is for theory. Like to theorize certain things, like what if, gravity had an anti-gravity matter? How would that work, right? That's how they discover certain things like that we can't necessarily see. Like we know there's an anti-gravity that kind of holds the galaxies together. If it wasn't there, everything would sort of collapse in on itself. But we haven't really identified how it works, right? All right, here we got a word problem, okay? Example 6. All right, so it says, a golf ball is hit from the top of a cliff, and it fell to the green located at the bottom of the valley. The path of the golf ball can be modeled by this relation. So this is kind of getting to an example where you can see the use of this stuff, right? The height is in H, is the meters above the valley. So typically we would use Y, but because we're dealing with a word problem here, we're using height. And then T is the time after the ball was hit in seconds. So we have H here, and we have T here in seconds. And our height is in meters. All right? It says, sketch a graph that represents the height of the ball versus time. Okay. So the first thing we'll probably want to do is think about the vertex, right? Because that's going to give us the total height, right? That's going to give us as high as the ball goes, okay? So who can tell me what is the vertex for this equation? RC. 3 and 60. I like it. There's your vertex. Okay. So what is the maximum height of the golf ball? First it says sketch a graph that represents the height of the ball versus time. So we'll sketch the whole thing first, okay? So we have that. Our step pattern is normally 1, 3, 5, but in this case A is equal to -5. So what's our step pattern going to be? Yeah, -5. Someone was saying it. -15 and 5 times 1, 3, 5. So 5 times 5? right? So we know, actually we don't normally consider the negatives in our step pattern because we know we're going down because it's negative. We're going to go 1 over and we're going to go 5 down. Then we're going to go 1 over and we're going to go 15 down. 1, 2, 3. And then we're going to go 1 over and we're going to go 1, 2, 3, 4, 5. Sorry? Oh. Actually, guys, sorry, I made a mistake here. See how this spacing is two squares? I just assumed this was 1, 2, 3. It's actually every second square is 1. Do you see that? So this is wrong. My bad. Sorry about that. So instead of going 1 square over, I need to go 2 squares over from 3 to 2, right? So I go 2 over, 1 down. Then I go, 2 over, 5 down. Then I go 2 over, 15 down, and 2 over, it's going to be all the way over. Yeah, it's going to be right here. Okay. Okay. Now, why do you think maybe that I didn't put the arrows here? Why didn't I put an arrow here and an arrow here? Andrew.
That's the point of intersection.
Point of intersection? What do you mean?
That's that's the y-intercept, sorry?
Yeah, so what?
You said?
I've crossed through the y-intercept before and put an arrow. Why? Teody. Yeah, so I don't put an arrow here because it's not going to go through the ground. It's going to stop when it gets there. What about here on this axle? Unless we have a time machine, I'm not going to go past 0 in time, right? I'm only going to go to when t equals 0, which is right here. That's why I didn't put the arrows, because I don't go past the ground. That's the height, and that is the time. All right. So now that we have everything, we can hopefully answer some of these questions. What is the maximum height of the golf ball? So max height is equal to what? Judain? 60 what? Yep. How long does it take the golf ball to reach its maximum height? RC. Yeah. 3 seconds. What is the height of the ball at 2 seconds and 4 seconds? Yeah.
2 seconds is 55 meters.
Yeah.
And 4 seconds is 55.
Yeah, 55 right here. 2 seconds, 55. 4 seconds, 55. What do you notice? Explain. What do you notice? So let me reframe that. What do you notice at 2 and 4 seconds? Let's try, Lucas. Yeah, same height. Sorry, I didn't show you this. Same height at 2 and 4 seconds. Okay, that's what we notice. We notice that it comes up, hits that height, and then comes back down and hits that same height at 2 and 4 seconds. What's the height of the ball at 7 seconds? Here's 7 seconds. What's the height of the ball? RC. 0. Good. No, the ball. Where is the ball? On the ground. On the ground. What is the height of the cliff? Remember, it's thrown, it's hit from a cliff. This is a golf ball, right? You hit off the ground. So what's the height of the cliff? Junior. Yeah. Height is equal to 15 meters.
Yes, sir.
Yeah.
How is that height 0?
At 7 seconds?
Yeah.
Because this is 7 seconds and the ball's already hit the ground here. At 6.5. So it can't go negative because it's hitting 0. So at 7, it's 0. Hits the ground and stays there. Any questions? All right. Hopefully you guys are doing pretty well with this, I think. Hopefully you're going to do well come the test. 7. Write an equation for the parabola with vertex -711, opening downward, and a vertical compression of a factor of 0.5. Ooh, who's up for this challenge? Josiah, you think you can do this? Josiah. Yeah, 7. You're going to write an equation for a parabola with a vertex of -711, opening downward, and a vertical compression of a factor of 0.5. So I'm going to help you out here, Josiah. I'm going to write the standard form, the vertex form. You're going to try and fill in some of these variables. Okay? There's our standard our vertex form. Sorry? X is -7? Not X, but H, right? So let's fill it out. Y equals, what's A? No. It has a vertical compression of a factor of 0.5. Yep, 0.5. Okay, we keep X the same. Now, H is -7, so what am I going to put here in the formula? +7, yeah. Squared, and then K is 11. Okay, there's our formula. Oh, and it opens down, so what do I have to do? What do I got to do to A if it opens down? What do I got to put in front of A if it opens down? Josiah, what do I got to put here? You don't remember? Negative. Right? When it opens down, it's negative. Okay?